Okay, let's take a look at our next and final project. So, for better or for worse, 2020 is an election year, and statisticians get a lot of work during election years. So there's a lot of common applications of statistics here. We're going to look at a fairly simple example. What I'll do is I'll post in Brightspace this early voting table here. And this is similar to the tables that we've worked on in class and on the homework. What you'll be doing is calculating some simple probabilities with these early voting numbers. So question number one is you're going to locate the early voting location that's closest to your home. You're going to choose two polling places for this problem. The second polling place is going to be whichever one is closest to your work. Now, if you're not working in addition to going to school, that's fine. You can choose the second closest one to your home. So when I'm talking about the polling places, I'm talking about these listed at the top. Now, if you click this link that I've posted here, it will show you the location of all these places. So you can scroll through and look at the different polling places. If you click on a map, it'll show you where they actually are. So you'll be choosing two for this project. So, and you can do this on your paper. The answer to question one is, where are the polling places? Just for demonstration's sake, I think I'll use, let's see, I'll use Carter and South. Your polling places will be different than these. So, what's next? For question number two, what is the probability that a randomly chosen Knoxville voter voted at your first polling place? For nearly every single problem in this project, you're going to use some form of part over total. So if I go to the spreadsheet, polling place one was Carter. Now, we're just saying what is the probability that someone voted there. We're not talking about any particular date. So I'm going to use the total number of people who voted at Carter, which is 873, out of the total of all Knoxville residents, which is going, or voters, which is this total here in the corner, this 35,389. So this is the work I want to see on your paper, is show me that you're using part over total. I want to know where your numbers are coming from. And then from there, we can punch it in the calculator. 873 divided by 35,389, which as a decimal is 0.0247. If I multiply that by 100, that will make it a decimal, which is 2.47%. Which means that 2.47% of people that voted early went to Carter. So that's question two. Let's see what's next. Question three, what is the probability that a randomly chosen voter voted at the second polling place? This is going to be nearly identical to the previous problem. My second polling location is South. The total number of people who voted there was 2,369. out of the total 35,389. So again, we simply divide those two. .0669, which, if we do times 100 or move the decimal 2 places, is 6.69%. Question 4. What is the probability that a randomly chosen Knoxville voter voted at polling place 1 on 2/23? So we need someone at Carter on 2/23. So if we check our data, we go to Carter and we go to the date 2/23, which is the last day. 267 people voted at Carter on that day. Again, out of the total of Knoxville voters, which is 35,389. Which is 0.75%. Which is a small number, but that's to be expected. That's only one polling location on one day. Question 5. What is the probability that a random voter from polling place 1 voted on 2/10? Similar procedure to the last one. Go back to our data. Carter on 2/10, that's 31. So that's 31 out of 35,389, which is 0.08%. Okay, what's next? Question 6. What is the probability that a randomly chosen Knoxville voter voted at polling place 1 or 2? So in my example, we're saying, okay, what is the probability that someone voted at Carter or South? Now remember your definition. The probability of or means we add the two together. So if we go back to our data, the total number of people who voted at Carter was 873, plus the total number of people who voted at South, which is 2,369, still out of the total 35,389. .0916 times 100, 9.16%. So we add them both together. So it doesn't matter if they voted at either or. It's not possible to vote at both. Okay, what's next? Question 7. What is the probability that someone voted at either 1 or 2 on 211? So if we go to our data, they can be at Carter or at South on the date 211. There'll be 59 people from Carter, 85 people from South, so we'll add those together. Makes 0.41%. Moving on. Question 8. What is the probability that a randomly chosen voter voted at polling place 1 on 212 or 213? So we're saying at Carter on 212 or 213. Okay. So if we look at our data, someone who voted at Carter on either 212 or 213 will be these 15 and these 19, so we add them together. Not very much. 0.096%, approximately 0.1%. Question 9. What is the probability that two randomly chosen Knoxville residents both voted at polling place 1 on 220? Now this is where we have to do a little bit more thinking. If we go to the data, what is the probability that two people voted at the same place on the same day? So two people voted at Carter on 220. Well, the probability that someone voted there on that day is 64 out of 35,389. But if we're talking about a second person, well, that second person can't be the same as the first person. So what we're going to say is that first person who voted at Carter on 220, we're going to push them off to the side, which means there's no longer 64 people there. There are now 63. We've also decreased the total to 35,388. Now, notice that we decrease by 1 in the numerator and in the denominator because we can't count the same person twice. This is the first person, we remove that person, and then we get the second. This is going to be very small. A very small number. It's very unlikely because the sample size is so large. Out of 35,388 or 89 people, finding two people that have the same location and date is very unlikely. Question 10. What is the probability that a randomly chosen Knoxville resident voted at either polling location 1 or 2 on 2/18 or 2/19? So if we look at the data set, either Carter or South on 18 or 19. So that's going to be this 45, this 63, this 133, and this 163. We're going to add those four numbers together. Still out of the same total, 35,389. Which is 1.14%. And that's it. We're done with the project.